Welcome back to the shop. Today's video will be the first of a multi-part narrated series of me building a 6-inch Bowie. Like normal, the series will be followed up with a non-narrated full build video set to music for those of you who cringe at the sound of my voice. Make sure to stay tuned to the end of the video where I'll be previewing a new tool in the shop that will be getting its own dedicated review soon. Many of y'all may recognize some of the initial footage here since this is the knife I forged during my budget Vever anvil review. I started by forging out the tip and worked it over the side of the anvil, creating a little nub that I cut off with my Hot Cut Hardy tool. Looking at the shape now, you can see a section of the blade that looks like it would be the edge. However, once I start forging my bevels later, this will curve up and be the spine. At this juncture, I should have had less of a curve here and more of a Viking sax shape to achieve the clip that I was aiming for. However, the 2x72 belt grinder fixes this issue later. As y'all just saw, I flipped everything around to isolate the ricasso and took advantage of my hydraulic press to do this with a flat die on the bottom and a drawing die on top. I started working my bevels on the near side of the anvil and up towards the tip. I'm getting better at forging these, but I am by no means a professional. However, that's okay because I have years of practice and the forge isn't going anywhere. To keep things straight without putting flat spots on my blade edge, I use a 2x4 as a swacker. Overall, this works pretty decent. I cut off the excess material at the tang and then drew it out. With the knife forged out, it's time to make some plans on what I'll be turning it into. Currently, I have a rough idea of what I want to do going into forging and then make a detailed drawing afterwards, but one day I'm hoping to be good enough to make the drawing first and then forge to it. After getting my drawing scanned in, I scale it and trace it in Fusion 360, export it as a DXF file, and then cut out a template on my diode laser. One of the first things I like to do if I can on a knife build is to use my DIY surface grinding attachment to get the flats parallel and cleaned up. This gives me a good starting point for the rest of my grinding and allows me to start with a pretty nice surface finish. In this case, I brought the flats up to a 320 grit finish on the SGA. Using the template we cut out on the gantry diode laser, I mark out my target profile with a carbide scribe. I'll make some tweaks here and there during the build, but having a nice profile to start with is great. Here you can see me fixing the clip on the blade that I talked about earlier in the forging section. A major advantage of a 2x72 grinder that will go horizontal is the ability to refine your blade shape during the profiling while keeping the spine square to the ricasso. It can be a little cumbersome to get everything set up, but it's easily justifiable with the results. One of these days, when space permits, I plan on having multiple 2x72 belt grinders, and one will surely stay in the horizontal orientation. For those of you who saw my recent 3D printing video, this is the jig I made in action. I'll be using it later on in the build to mark out target grind lines on my handles, which is what I really made it for, but I wanted to show that it can also hold a carbide scribe. The setup can be a little finicky, but it gets the job done for marking out some targets. I'm looking to potentially do a partnership with manufacturing and selling this jig in the future. However, in the meantime, I do have a few of them on my website if anyone is interested. My pre-heat treat grinding is done with a 36 grit belt. I like leaving some flats on the blade at this point to help me keep it all straight. The goal here is really just some bulk material removal and rough alignment of the bevels. While everything is still soft, I'll file in the radius of my tang shoulders with a chainsaw file and then get them good and flat with the carbide faces of the guide on the grinder. I didn't show it, but after forging I annealed the blade. I performed 2 normalization cycles at around 1600 degrees Fahrenheit before quenching at around 1525 degrees in Parks 50 with this 1084 blade. While the blade is still hot and smoking, I clamp it in my blade clamp in an effort to minimize any warpage. This blade was then tempered at around 405 degrees Fahrenheit for 2 2-hour cycles. For the bulk of the material removal post-heat treatment, I'll start back with a 36 grit belt and then quickly work to a 60 grit ceramic belt. On the disc grinder, I'm using some 220 grit and 300 grit paper to clean up the tang and ricasso. On this build, I don't plan on back cutting my ricasso, so I'm going to be putting a very gentle taper from the end of the tang to the shoulders to aid in guard fitting. Back on my grinder, I work up to a 120 grit belt. This felt like a good time to do some cleanup on the bottom of my ricasso, so I brought these flats up to 600 with some sandpaper wrapped around a small needle file. With the height scribe, I marked out a center line on the clip and found that my bevel grinding was a little off, so I made some adjustments on the side that was off with the 120 grit belt. This is the time to make sure everything is in line before grinding in the clip. I'm going to be using a waterfall grinding platen from my plunge radii, which was popularized by Mr. Kyle Royer. To have some targets to line up with on the edge of the platen, I'm using the Brian Bump file guide as a scribing guide. This waterfall platen takes some practice to get used to it, but if you have some patience, in general the results are great. I work up to a 320 grit belt here, making sure to apply pressure towards the bottom of the plunge. This reduces the chances of me grinding into the spine at the top of the plunge. With the plunges in, I set up the 8-inch contact wheel and the work rest at an aggressive angle in order to grind in my clip. About as aggressive as I can get the table without much fiddling around is 67 degrees. Before I start hand sanding the bevels, I go through a few sheets of 600 grit Rhino Wet on the disc grinder. This greatly reduces the amount of time I spend hand sanding on the bench. After everything is up to a 600 grit finish, I reinstall the file guide and clean up the shoulders on the flat platen. Next up is the new shop toy I mentioned at the start of the video, so hold on to your hats because we're going to be getting high tech. So I'm going to be putting my maker's mark into the ricasso of this knife with my new fiber laser, and this will be the first time that I'm using the fiber laser on a knife that I actually care about. So in order not to mess it up, I'm first going to measure the height of this ricasso and then match the width of this bar stock to that height and use this bar stock as a sacrificial test bed for my maker's mark to make sure that I have everything aligned and etching appropriately. In the future, this may not be necessary, but for this first go around, I felt like an abundance of caution is a good idea, just so I don't mess up the work that I've done currently. ComMarker recently sent me this machine for testing on the channel, and there will be a dedicated review coming out in a few weeks, but here is a sneak peek at what it can do. The main reason I wanted to test a fiber laser in the shop is for marking steel. The wavelength involved with these fiber lasers are much more effective at marking steel than that of a diode laser. In the upcoming review of this laser, I'll be comparing it to my standard electrochemical etching technique, as well as the diode laser for applying my maker's mark on the steel. Obviously, I'll go into the nitty-gritty details in the review, but for the sake of this build, you can see it's looking promising. Lining everything up was pretty effortless with the framing functionality and the fences on the bed. I ran 20 cross-hatching fill patterns at a 0.05mm interval, 26 Hz, 30% power, and 50 mm per second speed. After etching, I used some sandpaper to clean up the mark. All in all, I'm pretty darn happy with these results. I think in the future I could run this operation twice to get a little more depth, but I really like the crispness of the lines and the corners of this mark. Alright guys, that sums up part 1 of the build. I'm not quite sure how many parts are going to be since I have not finished this knife yet, but in any case, I hope y'all get some value following along with the process. Before signing out, I'm going to go over some housekeeping items. First and foremost, I want to say thank you for your viewership and subscriptions in 2023.
Thanks.
This channel had almost 15,000 new subscribers, along with accumulating 2.4 million views. It's super encouraging to see y'all's comments on these videos, and it makes me happy to know that y'all are gaining value out of watching my learning process in making knives. I always try to emphasize the learning in the last sentence there, just because knife making is a hobby for me and I still have a ton to learn in the craft. I'm also appreciative for the growth in my side channel, Redbeard Engineered, where I do non-knife making related projects, and last year we got up to 5,000 subscribers, with the most popular videos being the installation of that split system back there, as well as my data recap for my continuous glucose monitor while being a carnivore diet practitioner. I will continue to throw up my side projects there on that channel for not only my records, but also your enjoyment. Lastly, if you haven't seen it yet, I want to make y'all aware that I recently open sourced a large library of my knife templates. These are free for everyone to use, and I will be adding to them each year. If you want more information on that, I'll put the video giving that information in the description below and in the cards above. With all that, I hope everyone watching has an amazing 2024, and I'll catch y'all on the flip side.